When it comes to the Arctic Ocean sea ice melting, it's more than about starving polar bears. Metaphorically speaking, the Arctic Ocean serves as a thermostat for our planet. In the summer months, especially September, the sun heats the surface of the ocean water for 6 months, and then the sun slowly sets another 6 months. Sea ice then returns, but a bit less so than the year before. So for 6 months, solar energy radiates down upon the Arctic Ocean surface. When the ice melts, the ocean water becomes warmer. As the ocean water becomes warmer, it causes warmth to rise into the atmosphere. There, it plays a role, in part, influencing the stability of the Arctic vortex in the stratosphere. Also, the warming Arctic Ocean causes adjoining ice melt on coastal waters and the ocean. These two Arctic Ocean warming events are known as feedback loops. Soon, in a year or two, we can expect the ice-free Arctic Ocean. As a result, we can also expect dramatic climate change as well as this thermostat's dial to move Earth's temperature to a warmer statistical mean, average warming. What follows was copied and edited from the IPCC, Chapter 4, Arctic. The Arctic is undergoing the most rapid climate change globally, warming by 1.9 degrees Celsius over the last 30 years. For 2 degrees Celsius of global warming relative to pre-industrial levels, chances of an ice-free Arctic during summer are substantially higher than at 1.5 degrees Celsius, with permafrost melt, increased instances of storm surge, and extreme weather events anticipated along with later ice freeze-up, earlier break-up, and a longer ice-free open water season. Negative impacts on health, infrastructure, and economic sectors are projected, although the extension of the summer ocean shipping season has potential economic opportunities. Communities, many with indigenous roots, have adapted to environmental change, developing or shifting harvesting activities and patterns of travel and transitioning economic systems, although emotional and psychological effects have been documented. Besides climate change, economic and social conditions can constrain the capacity to adapt unless resources and cooperation are available from public and private sector actors. In Alaska, the cumulative economic impacts of climate change on public infrastructure are projected at $4.2 billion to $5.5 billion from 2015 to 2099, with adaptation efforts halving these estimates. Marginalization, colonization, and land dispossession provide broader underlying challenges facing many communities across the circumpolar North in adapting to change. Adaptation opportunities include alterations to building codes and infrastructure design, disaster risk management, and surveillance. Most adaptation initiatives are currently occurring at local levels in response to both observed and projected environmental changes as well as social and economic stresses. In a recent study of Canada, most adaptations were found to be in the planning stages. Studies have suggested that a number of the adaptation actions are not sustainable, lack evaluation frameworks, and hold potential for maladaptation. Utilizing indigenous and local knowledge and stakeholder engagement can aid the development of adaptation policies and broader sustainable development, along with more proactive and regionally coherent adaptation plans and actions, and regional cooperation.